episode 3 of the All Things Facades podcast, and we have Nick Bagatelos joining us. So, all of my glazing community, I'm sure everybody knows you. You're well known throughout, but I do have people on the audience outside of the glazing community. So, before we really dive into any technical concepts around glazing, why don't you give us sort of the 90-second spiel around maybe bags, what you built in the California market, and a little bit of your background?
Yeah, so Nick Bagatelos, I'm a glazer. My dad was a union installer in San Francisco, and shout out to my dad who's passed, but he was the lead glazer on the Bank of America Tower in 1970, which is the tallest building west of the Mississippi. We started a business together when I finished college in '87, and I had a non-union company for a decade with my dad and my brother. My brother and I split off and built a union company that designed, engineered, and manufactured unitized curtain wool. We built that business steadily for about 25 years. And in the last 2 to 3 years, I sold that business to my brother. And I've been working on super energy efficient exterior wall systems and this single pane retrofit with vacuum glass that I think we're going to talk about a little bit today. But my passion in this industry really evolved when I started doing innovative things and I started using technology to help my manufacturing. So using BIM processes, lean management, and then the passion was about building net zero envelopes and being a part of a net zero building.
What's interesting, I think people in the industry know you as being an innovator, as being very forward thinking, and you've always been on this train of pushing more sustainable systems, a more sustainable approach, energy efficient systems in general. And you were once quoted saying everything has to start with the codes. And so I think about it, recent code enactment in terms of something in New York like Local Law 97 regarding energy building consumption, Local Law 15 in terms of bird-friendly glazing. It seems as though these code changes are what really drive change in the industry and almost force it. So how has that sort of played into the last couple decades of your trajectory?
Well, I'd say I think my quote now, looking back at it, may not be perfectly accurate. So I think if a technology can't hit the right ROI, the codes are required. So there's no ROI in bird glass, so you have to enforce it with code, right? But if you look at low E glass pretty much went from a $3 per square foot product in '99 to a 75 cents per square foot product around 2000. And the adoption curve hit that hockey, stick in about 2006. And by 2014, there was 100% adoption in North America and in Europe. So it went from 10 million square foot to close to 3 billion square foot of product. And the codes didn't kick in until about 2009 or 2010. So I thought that back then, but as I've researched it, I think it's really about getting ROI on the innovative product. So, and I think that's what happened with double pane glass when it finally went from, an idea in the 50s to real technology in the 70s. I think the same thing happened with low E when it was a great idea. It worked 10 million square foot a year in North America, but, by 2014, it was 1.7 billion square feet. So
what
I really
do you think
it's
ultimately bringing those systems to market and being able to produce at scale, is that ultimately what drove the change when you saw in the early 2000s when you were seeing low E everywhere?
Yeah. I think the fact that the large glass manufacturers shifted from sort of batch fabrication and vacuum deposition to the large scale coders that were just snapped on to the front end of the float. That brought the price down exponentially, and it made the product, you had to use it because the value proposition was a 1 or 2 year payback.
So
So.
how have you seen the implementation in market specific geographies, like California where solar heat gain is so critical, and then you go to the Northeast where it's driven by U value, and then Miami where it's driven by the hurricane requirements. Do you see mass implementation nationwide, or do you think these changes will always be very market driven?
Yeah, I think they're going to be market driven, and you need an ROI that goes across the different markets. I think we're going to talk about vacuum glass in a minute. It has an impact everywhere, and it's a dramatic impact in a place like Southern California. But the impact in the northern regions is 4 times as effective. So, and I think the same thing with the low E's. The low E is important, and solar gain is important in those northern climates, but it's dramatically more important in the southern climates. So, like low E, the adoption was almost immediate in California. We didn't install double pane glass until the year 2001.
Hmm.
There wasn't I'd been in business for close to 20 years, and I had maybe installed one double pane project for the state of California. But in 2001, Governor Gray Davis signed legislation that every building over 20,000 square feet had to be double pane, and it shifted immediately. Now, it wouldn't have been able to shift if it wasn't for the fact that the Northeast and Canada and the Midwest they had been using double pane glass for 15 years. So the production cost had dropped. So when that legislation was put into law in California, the price had already gotten to a fast ROI, but the market wouldn't change until you forced them. So
So were you seeing a lot of monolithic glass just with or effective solar heat gain low E coating technology? Did that work in the
no,
California
what we
market?
had right up until about 95, 94, we were using just tints. Gray bronze tints, gray light 14. I did a lot of gray light 14 in the early 90s. It wasn't and those pyrolytic coatings came in. Um, and they were pretty much the rage in California for about 6 or 7 years. And then when the single, double, and then triple silvers hit, that's where we really got full adoption. And the code shifted really dramatically fast when the product hit the price point.
So did you see as insulated glass units were sort of gaining traction within the marketplace, is that the same sort of timeline that you started unitizing systems and seeing that growing attention in the market?
Yeah, I started unitizing in the mid 90s, and I think unitizing is fairly common in North America now. But what is it? Maybe 3% of the North American commercial market. It's still not, um, you know, used as much as maybe it should be, or it could be. But I moved towards unitization because it was a differentiator.
Well,
It
that's
was
what's
harder
what's
to
so
do.
strange to me is that, I live in the New York City world, high-rise window wall, curtain wall, prefabricated systems, and you see a lot of that in the California market, but that's just not what's happening throughout the country. You're right that it's such a small sector of the market.
You need projects that have to go fast, that require quality, right? And if you're building something in the Midwest for a hospital, they don't really care. But if you're building a tech facility in Silicon Valley, they want that thing done. They want the building designed, engineered, and built in 18 months, which it always takes 24. But you don't have time to put 16 glazers on there stacking sticks. It just doesn't work.
So what did
So
those conversations in the early 2000s? You were sitting here being innovative, bringing unitized systems to the market. Everybody was being hit with all these new concepts, and all of a sudden you come out of left field and you start introducing concepts like BIPV and dynamic, all these different crazy topics. Was it just so over everybody's head, or was it well received?
So what I'd say about that is I learned a huge lesson about the industry, about innovation. Everyone wanted to hear it. Everyone took meetings with me all over the country. I had meetings in New York and Chicago and Seattle. Even though I wasn't soliciting projects, people wanted to hear about this BIPV and wiring glass for electrochromics. But what happened is no one bought it. And there was a couple of problems. One is ROI, but ROI is with the tax incentives that they had and the way I put the product together, the ROI was rapid. And what I learned after that, I thought if I get the price right, it'll work. There is a cross trade problem that's based on liabilities. So our industry is so litigious, and if you have a problem, the problem can cost more than the full contract in a matter of days if there's rain or there's a problem with a structural integrity of a system. So when you go to an owner and say, hey, I want to put in PV, and the architect's like, I like that, but I don't want to be liable, then you say, hey, we got to have a high voltage wiring. My old man told me, Nick, it's never going to work. And I'm like, what do you mean, Dad? Everybody loves this. He's like, the electricians are going to be scared of leaks, and the glaziers are going to be scared of getting electrocuted. And you know what? It wasn't as simple as that, but that's what happened. The glaziers raised their price because they didn't know what they needed to do to wire it. The electricians raised their price, and so you couldn't get traction for mass adoption. And then the third part is you could get the ROI through the tax incentives. The problem is transparent photovoltaic glass has extremely low power density. It's like a 2% of the photons that hit it become electricity. And the stuff you put on a rooftop or out in a 10,000 acre solar field in the desert, they're at like 22%. So the power density is the problem, I think, with the BIPV stuff.
I've heard Elon Musk do interviews, and people ask him, can cars basically be self-sustaining if you were to have some type of roof which had a solar panel? And he said it's impossible. You wouldn't have enough surface area to power the car. And so
Right.
Just thinking about that for the facade area, is it just too inefficient?
The most you're going to, and well, think about this. The north, 0. There's no light on the north.
Right.
And the east is in the morning. You don't get much. On the west, a little bit, but it's only, so you got one of the 4 walls to generate. And then you're only at about 2%, energy efficiency with the panels. And because they're tilted vertical, you lose about 75% of that. So you're like 1.5%. It's the place for BIPV in buildings is for small collectors, I think, to collect enough juice to charge a battery that's in the frame, that then that battery does all the electrical functions, like shifting the electrochromic, like operating blinds, things like that. You need direct current PV in a low dose to charge a battery so that you can have direct current, low voltage activities on a window. That's the future, but it's a small market, man. Those devices need to be like $6.
And so in the few facades where it's been implemented, whether it's BIPV or dynamic glass, do you see it uniform throughout the facade or only on the elevations where it's applicable?
Well, see, that's the problem. Architects want it all to look the same.
Right.
And then all the stuff on the other walls is kind of waste. You don't need low E on the north elevation of a building, but the whole building has low E, right? It's $1 a foot or whatever. It's not going to make that big of a difference. But I think when I look at what buildings will look like in 2050, I think every elevation is going to be a little bit different. Some you're going to want super high R value. Some sides you're going to want to collect energy. Some sides you're going to want to have, like on the west elevation in Sacramento, California, where it's 116 degrees at 4 in the afternoon. In August, you need to pump up your HVAC. You need 40% more tonnage for those 36 days. If you put electrochromic on the west side, you've got a real value proposition for those buildings in Sacramento. So I think the facades of the future are going to look different on every side of the building. That's my thought. And I'll tell you
I have
a
so many
little story
different
about one.
directions I want to go here. So Before I go in, how would you
You want me
approach
to
the
tell you a
market?
story though, about? I started installing Gray Light 14 in like 89. And, I saw all these black buildings going in Sacramento, in Silicon Valley. I went to New York and there was a couple buildings with, the Gray Light 14 glass and red brick. And then they were everywhere all over the country over the next 10 years. I thought architects picked the exterior design of the building. And I know there's some architects listening. I'm sorry to let you guys in on this, but every building in North America after 1960, literally the skin is based on the glass technology. You have those you have the tints that changed colors from the 60s into the 70s. The reason the 70s picked those bronze and gray colors is because that's what the technology was. Then you went to the Gray Light 14. Then you had the super reflectives like Guardian's SS8. And that was the technology, but they didn't want the reflectivity. After 6 or 7 years, it shifted to the pyrolytics, then the low E's. So the exterior skin is always based on the glass technology and the colors you're able to provide with the technology that provides the performance.
So you're saying, in essence, the glass is a limiting factor.
Yeah, it's the limiting factor, and then the driving aesthetic factor as well. That limiting factor is what drives the aesthetic, I think.
So when having these conversations across different markets to different end users, we talked about codes, but what about government incentives and tax incentive programs? I've been thinking about, they had this Inflation Reduction Act here in New York where you get a tax credit back if you use dynamic glazing. And I didn't see it gain the traction that I thought it would. And so how do you see the implementation of government programs or local programs to try to incentivize owners to upgrade existing buildings?
Well, I think local law 97 is obviously a good example. They're going to fine people if their buildings don't hit certain energy efficiencies. And I don't know the law of that well, but it's more like you have to hit a level. Doesn't matter how you get there. I think that's really important. If there's going to be legislation, it needs to say, hey, here's the whole building, the skin R value and the, energy intensity per square foot, get there. And then use the hundreds or thousands of tools that are available that might be better in certain markets, or shit on a corner. It might be better on this corner than on that corner in the same city, right? Or, I live in San Francisco. We have like 9 microclimates here. So, you need to come up with solutions that are project and location based. And
So
I
we
think,
see something being implemented with 97 in New York, Berto in Boston. We haven't seen the effects yet because they haven't gone into implementation. And there is the question, to play devil's advocate, the building owners that will just say, you know what, I'm going to pay that $40,000 fine instead of upgrading my buildings. I think it's an important point that you stated, that as long as we're trying to meet certain benchmarks and we meet a threshold, hey, you want to upgrade your lighting or your mechanical, leave the envelope alone as long as you reach that threshold.
sure.
Um, what about in other markets? Do you see California or other markets trying to tackle existing buildings?
I know the folks at the California Energy Commission, and like I put a lot of thought into vacuum glass and improving R value on skins lately. When I talk to them, they love it. And they said, you know what, Nick, when you can show us that the price point won't raise the market price dramatically, and there's capacity to fulfill the state of California, we will write it into the code, and the legislature needs those 2 pieces of information before they will allow us to create mandates. So I think you need the product before you're going to get strict enforcement of things like that. And I know there's some stuff going on in the state of Washington. I know California is talking about it, and I think they'll probably. So I think you're going to have leadership in that area from large cities. And then the innovation is going to come to them, and then it's going to get more cost effective, and then it'll spread across the country.
Okay, so when you mentioned, it's interesting, you said, the electricians didn't want to worry about the glazing, the glaziers were worried about the wiring. Totally get it. Let's put ourselves in the developer or the building owner's shoes and think about common objectives that you might hear. What would you say to from a warranty standpoint, from a maintenance replacement standpoint? Have you heard objections over the years about that? Will this company still be in place? When you buy a building envelope, you want it to last 30 plus years. So how do you get that type of assurance?
So I think I think that's a third or fourth level question, but I think it ties into the key part, which is risk and liabilities, right? That's where everything that I did my whole career, the reason we went unitized is it reduced risk. All of the leak potential was handled in the shop. So we could have a lot more quality control. When you get out to the field, it becomes much more difficult to wrangle that liability, and that is the driver. If you can reduce your liabilities by implementing quality, then you can have a company that lasts for 30 years. If you don't, you will get busted somewhere along the way, and you're going to lose $2 or $3 million because of a quality issue. So if you then apply that to, say, BIPV, nobody's really doing it. I started that company. I did 3 projects across North America, and that's all there was to do. There was not scale potential, at least 15 years ago, right? And now I still don't think the power density is such that it will get you there. And if you're only doing 1 or 2 or 3, 4 jobs a year, you can't really develop the quality control. I mean, look at Conair's Fastset 400 system. You know, that product has been installed probably like 200 million times. Any problems happened in the first 1,000 installations and it was done by the 5,000th. Well, there's probably only been 100 BIPV, installations in North America. So yeah, I think that wiring part is something that's really difficult to handle within that risk, aversion from everyone, from the owner, from the architect, from the contractor. The contractors have their setup and they know what to expect from a glazer and they know where the glazer is going to fail so they can track that. With BIPV, who knows, right? I mean, they don't. I happen to because I built them, but most people don't.
So I'm very curious on your stance here because I've stepped on some toes and gotten in trouble a few times over the years bypassing general contractors and going directly to owners. And so when you were a glazing owned Bags all those years, because you were bringing innovation and new things to the market, I'm sure your sell had to be directly to the owners, especially if you were pitching this to the GC and there was added liability or risk on their end. Why would they be pushing that move? So how did you balance that dynamic of communicating through the GCs versus, finding that balancing act?
Well, so I'll give you a story about the innovation stuff. I pushed that stuff for 3 years at BIPV. I got meetings with everyone, Gensler, SOM, everyone in there, all over San Francisco, New York. All of their offices wanted to see me, but then none of them specified it. And if they did specify it, it got value engineered out. And then what happened was, because I was in the room, my unitized curtain wall company doubled, and then it doubled again. So, and it doubled through the contractor. So I did meetings with the architect and the owner, but I usually went through the contractor to get to those folks. And then I learned the lesson pretty rapidly that, hey, it's my unitized curtain wall that's going to do it. And I need to do that. That's what's going to give me growth in my company. The BIPV was fun. I love it. It's a passion, but got to make money. And the design build process isn't through an owner. It's through a contractor. And I always offered ease, lower liability, speed, and then price. You know what I mean? All of those, but in that order. So I've always worked through those normal channels of the contractor. And I get it.
Eventually, did you have the general contractors selling it?
The general contractors that we negotiated with for 2 decades pretty much had me and my brother and maybe 3 other glazers in the Western US that they relied on, on a certain type of job. And we shot for something between, 40,000 square feet and 200,000 square feet. and it kept the big guys out and it kept the little guys. So we sat in that market range that was good for us on the design build side with the contractor. So, you know, the hospital groups in California, I was favorites with a few of those guys, a couple of the universities. So yeah, I developed ownership relationships, but I was always very, very careful to keep my communication through the contract. I always asked before I talked to an owner, I'm like, hey, GM at Turner, what do you think? You want me to talk to him? Yeah, go ahead. Or not on this one. You know, we're worried about, you know, getting our structural contract done. We'll bring you in there in 2 to 3 months. I know
Yeah,
the
maybe
guy.
I need
I
to
know him.
listen
I've done a job
carefully.
with him.
Maybe I
Yeah,
need
they're
to
like,
listen
no, no.
carefully and learn this from you and stop stepping on toes. All right, so you and I are a little scattered, and I know we need to keep this focused because we can go in so many directions. So I ask a lot of those questions about bringing new things and innovation to the market because I know your primary focus, you know, the past few years as we spoke and moving forward is vacuum glazing and VIG. So I was really trying to harp on those experiences because you know, I want everybody to learn from your wisdom, but also what you're experiencing today. How do you learn from those decades of trying to bring new things to the market, and how would you approach it differently today? Because honestly, a lot of the objections you've heard in the past, you're probably continuing to hear on an ongoing basis.
So on vacuum insulator, I've been watching that product for about 15 years. I saw it in a science and technology center about 15 years ago. And I'm like, why do you have a piece of glass in your freezer? And they're like, touch it. I touched it. And I'm like, what the hell is that? They're like, that's vacuum glass. And I'm like, that's not even cold. I want that. I want to sell that. And they're like, oh, it's still prototype. Well, so I've watched, and the technology, I believe, is ready to go. And what's really important to me in selling to owners and getting past the first hurdle is, look, you cannot single source in this industry. You have to have options. So I'm thinking of vacuum glass as a black box. And getting people to understand that the technology works. I mean, if you've got test results and you've got a warranty, people will believe it. So, I mean, that's the first piece. And we've got multiple people from all over the world bringing glass into North America. And we have domestic production, and it sounds like may have production in Mexico with, you know, so we're there. We're at that precipice where we're about to have product that will fulfill demand of the people who need it and want it. So first of all, I would say you don't go to a guy who's building a retail center in central Pennsylvania. They're not going to buy it. You go to people and corporations who are worried about ESG. And there's a lot of them, and there's drivers outside of price that they will be that will drive them towards the decision, right? So I think those are two key things. We can't do single source. We need a black box. And we also have to be conscious that there are only certain, you know, owners that are going to really want this. So focusing on them means getting the product into the places where it's needed the most and can give them the best ROI. ROI might be money, but it also might be the sustainability piece of the ESG, right? So I think people might be a little bit worried about the warranty, but I know enough about the technology that the product is going to last longer than a double pane unit.
So
And it,
who is that avatar or that owner end user that you think would receive it well?
well, I think a company like Google, I think anyone who has those type of external pressures because of their employees, they're going to be good. Anyone who has a need for fulfilling their carbon global footprint, they're going to be good candidates. I think institutions, because something like vacuum glass and a single pane retrofit, it's less than a 10-year ROI. And in some buildings, it could be 3 or 4 years. If it's 3 or 4 years, I think almost any owner, if they know that it's available, will do it. If you're at 7 or 8 years, you're going to lose a lot of the developers, but you're going to get companies like these firms that want to do the equity, sustainability, and governance, right? But if you're at 7 to 10 years, every institution in the country is ready to do a 10-year ROI. So hospitals, universities, anyone who's going to hold the building for 20 to 30 years, they're ready to do it today. I think the the biggest problem is nobody knows this works. People in the glass industry have been hearing about it for decades, but everyone thinks it's a false start. I don't believe we're at a false start. I think we're at the place where we're going to have product on the ground in North America, and we're going to have demand is there if the product can be delivered. That's what I believe.
So what do you think it takes to spread awareness or gain this knowledge? I mean, I posted yesterday about how I still go to certain markets. I'm not going to name projects or specific cities, but I still see storefront stick-built glazing going in 18-story high-rise buildings. And so when you just realize it almost blows your mind that, a unitized system is a whole new concept. So now imagine bringing vacuum glazing to a market. It's just, you're going to seem like the guy who's in left field.
Well, but here's what I like about vacuum glazing. First, so if you take a piece of electrochromic glass or BIPV glass, put it in a window frame, you need to drill holes, run wires, connect adapters, make sure you have like energy control systems. There's a lot that goes into that. You know what you do with vacuum glass? You put it in the hole and push in the gasket. It's no different than going single to double pane or going Viricon to PP or PPG or Vitro, right? So I think the adoption because is a lot easier because all you're really just you're not doing anything different to the framing systems, which when it comes down to it, it's the framing systems that are difficult. That's where the product leaks. That's where you get the energy efficiency or not. So that's I think the adoption is understanding that it's available, number one, and then getting the price point so that you have under 5-year ROIs.
Okay, so let's say you're at the right price point. Now think about that end user that would want to die, an institution that would say, yes, let's give this a try. We want to be the,
right.
The example, the staple of it. Where do you see the balance of, sourcing domestically versus overseas? And if going to an overseas supplier, I'll tell you, I've been doing lunch and learns lately, either in architects' offices or facade consultants. And there's been times I've gone in there and I start talking about vacuum glazing and they show me a sample and I look at the company, somebody I've never heard of. And so for them to gain the confidence that they can do their due diligence, this person has done the accelerated weathering testing, cyclic testing to ensure the system's going to perform. Do you think they're going to be very, very, very cautious about who they go with if for the end user that would go forward with vacuum glazing?
Yeah, absolutely. I think not many people know much about glass, so I think there's going to be some products that are put into the market that maybe shouldn't be here, or that the lead times are such that it's going to make the project difficult. But I think domestic supply is the driver. Until there is, domestic supply that can be guaranteed, it's going to be novelty, like electrochromic. It's a novelty product. That's just the reality of it. So I think we need manufacturing on the ground here before we're going to get adoption.
And
any
so
type of scale.
Are you, in your head, I'm sure you're going to say there's a little place for it in every sector of the market, but when you think about it, does your head first go to, I don't say new construction curtain wall buildings, or are you really thinking about those historic preservation, old rehab buildings?
Well, kind of just to the right of your left hand. So I think the ROI for a single pane retrofit in an existing building is a slam dunk. I think the only barrier is supply and understanding that it's possible. And I'll give you a quick example. I built a brand new curtain wall for a 1970s building, Turner Gensler Brookfield, 1970s building, downtown LA, 70,000 square feet. They removed the tenant, demoed the interior, tore out the exterior skin, found toxins. I built a unitized curtain wall, installed it there, 3 years of design with the city of LA. And it cost about 14 million, not for the glass, but the glass is about 130, 140. There was 20 in demo, 30 in toxin remediation, not even figuring in a loss of a tenant in 70,000 square feet for 3 years. That's more than the freaking building's worth almost, right? So if we could have taken vacuum glass, pulled out the old glass, pulled out the gasket, put in the new glass, put in a new gasket, we would have been done in 6 months, and the performance of the vacuum glass would have been better than the brand new unitized curtain wall with double pane low E, and it would have been half the price. So as soon as people, and I don't know the numbers this year, but there's about 60 million square feet done the hard way. And I call the hard way, tearing everything out, removing a tenant, starting from scratch. That's 60 million square foot a year in North America. We can do it for half with vacuum glass. So I think that 60 million square feet, as long as, if you tell an owner, hey, you're in contract with a glazier, you've got a $5 million contract, and the glazier goes to him and is like, hey, we're supposed to order the metal in like 3 weeks. I can do it for half and it'll perform better. The owner's going to go, wait, don't order anything. Tell me what you're doing. You can do that? Show me the results. Give me the testing. HVAC guy, is that true? Looks like it's true. You can shift those projects in a matter of 3 weeks. So that's where I think the first products hit the ground.
So, part of the reason I wanted to have this discussion with you, to be fully transparent with everybody listening, I'm a window replacement guy, so I would push immediately replace the frames. But I think there's a time and place for both approaches in the market. And,
Sure.
Kind of back to the beginning of this discussion, is it dependent on the specific climate or geography you're in? So if you're in a Northeast climate or in Canada where U factor is everything, you're going to have to replace that non-thermally broken frame. If you're in California, for instance, or another climate where it's primarily driven by solar heat gain and you're not limited by that U value of the existing frame, is that really where your head is going or what you're targeting?
So the models that I've created show something like this. For an existing building with a non-thermally broken frame, right? In Los Angeles, you replace it with an R15, you replace clear glass in a non-thermally broken frame with an R15 low E, triple silver low E. You've got about a 20% reduction in energy. And if the owner happens to be redoing the HVAC system at the same time, which is part of this whole energy service, industry that's like 9 or 10 billion across North America, you can reduce the tonnage by 20% of the new HVAC system. If you do that, your payback is down to like 1 or 2 years. With in Southern California, you go north and, say Toronto or New York, it's about a 40% reduction. So, that's where there's going to be a lot more rapid adoption in the northern climates, but it will come to the southern climates, especially when the price point starts to get close to price parity with double pane.
And so where I play devil's advocate is I could see a really strong need for that in California. I'm trying to just picture a Boston winter where you have a non-thermally broken frame and then you put a piece of VIG in there and you leave that frame in place. Isn't that just going to be, icicles forming along that non-thermally broken frame? I'm talking extreme heating dominated climates.
So I would say, I have to say, I'm from California. I understand that there is condensation, but I've never seen it. No, but I mean,
we're talking different languages here. No, it's true. And so,
right.
80% of the country, that might not apply.
Well, what I would say is take a Rovex thermally broken paint it black, put the glass in, come down the side of the building and glue those to your frame, you've eliminated the conduction. So what I also is there's 60 million square foot done the hard way today. I think there's 120 million square feet that people are like, I'm not spending $14 million. Brookfield will. The other guy's like, nope, my dad gave me this building. I'm making 140,000 a month on it. I'm not going to do that. But if you're like, but the people who are looking at it are maybe on the edge and they're going to do it in 3 years instead of today, they will. So I think the 60 million square foot market will rapidly grow to 200 million square foot a year of renovation. And I think
where is the point of diminishing returns if you look at a standalone vacuum unit versus a hybrid insulated unit? And, I was asked this question yesterday and I didn't have a very clear answer. With the performance that you get out of a standalone vacuum unit, to then add an additional, a hermetic perimeter seal, an additional pane of glass, that additional, what do you go from an R what to an R what? And at what point is it just not worth the extra expense, not worth the extra weight? And so forth.
Well, I think you might get 3 points. So if you're an R12, maybe you go to an R15. That's been my experience. I got a piece of R12 glass, put it in a hybrid unit. I got it up to R15. So 3 points. But here's the deal. When we're selling glass, it's R3 and you go to R12, why do you need R15? I think, and if you're going to add $6 to $9 a square foot on top of the 25 or 30 that already is, I just don't see that as a driver. I think the reason we may have that over the next 5 years is, number one, because every system in North America is made for double pane glass. So putting in shitty little adapters and stuff is not the way to do it, number one. And then cutting a new system, it's a freaking $1 million to cut a new system. So yeah, I'm making one. There's like maybe 3 or 4 people believe this is going to happen. I would imagine you guys are, but that you're going to have real momentum before companies like Conair are going to throw away 250,000 dies or 22 million dies that will now be worthless. I think that is part of it. I also think there's a lot of people who fabricate double pane glass in the country. So if they don't have something to do, there may be some pushback from the industry, right? And I anticipate there will be, so that's, my couple of ideas on the hybrid. Here's the deal. I'm not going to propose a hybrid to anyone, but I'm not looking at a US market of $1 billion in sales. I'm going to look for the niches that fit my skill set, and I'm going to target those across North America.
So right? The primary use case and focus right now is the existing building market. New construction is not really at the prime sort of focal area for the VIG sector.
I don't think so, because when you're doing a single pane retrofit on an old building, it's a piece of crap building with a piece of crap system that they just want some better performance. They're willing to put 3M films on there. You're doing anything. You don't have you try to do a high rise with Norman Foster with VIG, man, that's going to take months of testing and hand holding and maybe 2 years before they're like, okay, we can put that on the 70th story of a building. But when it's, a building on Wilshire corridor that's Gray Light 14, that's 22 floors, and it hasn't been remodeled since 1970, and someone just builds a brand new building that's beautiful and clean with low E glass, and you go to the owner and go, hey man, for $4 million, I can make your building look just like that, and it's actually going to perform better, and you can tell them you have the most green product in the world. You might be able to beat them on your tenant competition. Those guys are going to go, yeah, I'll do that.
So I don't know as much about the storefront side of things. What I'm learning is in these cities like a Seattle and a Boston and now coming New York, where you have this envelope backstop, in essence, call it a 10% backstop. It tells you that historically people would trade off a poor performing envelope for a better roof, a better mechanical system, better lighting, building controls. Now they're saying, I don't care what you do in all those other sectors, you can only perform a certain percentage worse than code. So because of that, all of a sudden we're seeing the adoption of triple glazing in a lot of curtain wall buildings. And so this whole idea of the battle of the window versus the wall, and are we going to start seeing less highly glazed curtain wall, more punched window projects? What is the answer there? Do you think we see lower window to wall ratio or just the adoption of more triple glazing?
Here's the deal. I'm on LinkedIn. If anyone wants to take bets on this, I'll take them. I think the amount of square footage on buildings is going to dramatically go up. That's my prediction. So, and I think every architect every time would put more glass, but they can't meet the codes, so they don't. Oh, and then they can't make it comfortable, right? But if you've got a piece of R17 glass and another piece of R17 glass, you got an R30 window, better than a wall. And you know what? It's a lot easier to maintain glass in the field than it is to maintain bricks, paint, stucco. So is that going to be evident in 24 months? No. By 2050, will people look at it and go, why would you use stucco on a building? I think I think we're going to move towards more glass.
And
That's
so,
that's my prediction.
I think about some of the objections, the pillars, which, I did a video recently and I was blown away. I've seen multiple samples from suppliers now. You can't even see them. I mean,
No,
relative to what you see here with Bird Friendly in New York, it's nothing compared to the
it's
the
nothing.
the frit pattern. So you get rid of that. The port, it's becoming smaller and smaller. So the third thing is the size limitation. And I think right now we're roughly at maybe 5 by 8. That's some limitation I've heard tossed around, maybe 6. But I don't know. Do you think we'll get to a point where we go bigger than that?
Of course. I mean, look, you just need the drive. I mean, there will be differentiation after 5 years, but in the first 60 months, it's just going to be, and think about it. How many unitized curtain walls are wider than 60 inches? They're just not. 60 inches nice. That's why I think they're building the 60 inches. It fits. And you know what? Hey, Mr. Architect, you got a horizontal. Is that okay? I don't want a horizontal. Well, okay, you got a horizontal. Will Norman Foster let you put in the horizontal? No. Will every single tech company in Silicon Valley allow you to put a horizontal? They're like, yeah, why would you even argue? We can get performance that's 500% better and you got a horizontal at 36 inches? Yeah, I just don't think size is not a problem for 88% of the North American European market, right? Maybe 12%.
The first thing, it's interesting. You go overseas to, Europe, Germany, you see all tilt-turn windows, all triple glazing, all highly thermally performing walls. And it's just the norm there. And it just hasn't come here yet. And it's slowly, slowly coming. But it just feels like our industry in this country is so slow to adapt innovation and new technology.
Yeah. We're I think it's the litigious nature. And the other thing is, I've been to Germany. I was a Schuko rep. I saw their net zero energy building in 2006, a 300,000 square foot office building. I'm like, I wrote about stuff like this in my journals, and this is like Willy Wonka for glazers. Wow, and that really stimulated, my interest in innovation. Um, but they're driven by codes. They've got more social democratic countries that drive that. And here's the deal: it's freaking cold there. Half of this country isn't cold. You know what I mean? So when you're in Germany, you got no oil. you need to do that. So they've driven that through, and the thing is, maybe in the southern places like Italy, you don't have that demand, but they don't build windows. The Germans build the windows, right? So, um, that I think they're going to have to follow us, because I think the innovation in vacuum glass is happening in North America, and we're going to spread it to them. And
Sure.
frankly, it's, it's 300 to 500% better than double and triple pane.
Well, have we seen adoption overseas?
Zero. The only place that there's that I that I know that there's been production steadily is NSG. I don't know if I can, but in Japan, and their product's not tempered, so they can get around it there. But there's still only one factory building it. It's just, until you get the R values into the 15 to 20 range, the price point through production, you know, get it trending towards the same price as double pane. You're and then the scale production, so people know the product is available. I think those things are the drivers at this point.
So on a final note, I'll ask you, what does it mean to have that first example in a market where people can go up to it, see it, feel it? I remember our first New York job with the bird-friendly UV interlayer. It was a office to residential conversion. We had every developer, every architect come looking at it because they could finally see a full-size example. And so getting that first VIG project in the market so other building owners can see it, how important do you think that is to mass adoption?
You mean the single pane retrofit stuff? Or, well, there's projects all over North America that, NSG has done over the years. So there are projects for people to go look at. I really think the key is finding the owners and the contractor and the glazer who is going to do it the hard way. Tear out the skin, start from scratch, and do a new storefront or stick wall system. Let them know that this is possible, and if there's supply, they will buy it. I think of it as a value engineering process rather than an innovation. I got a VE. What's the VE? I cut the price in half and the performance goes up by 15%. Well, that's VE, right? That's value engineering, not changing the gasket from silicon to EPDM because it saves you a couple cents. That's not VE. This has the potential to drive. I mean, if there's 60 million square foot at say it's $100 a square foot, what is that? $6 billion in retrofits going on. If you can go to the owners and go, it's 3 billion.
And so
Done.
did NSG come to the market saying they saw a need and they said, this is our approach, this is who we're going to target? It's smart. It just seems very, at the time, forward thinking.
I think it was, I don't know, because I wasn't watching them 10, 15 years ago. I think they tried all over, and the place it stuck was the place that it's supposed to stick, right? I don't think anyone from NSG was like, hey, this is where we're going to go. I think that's the only place that there's value today, and a lot of these old buildings don't have tempered glass, and maybe, they'll allow you to put a piece of temper next to the door because they're looking for a solution, or you've got the historic. I think most of it's been done in historic,
Yep. Yeah, and
buildings.
so finding that balance, especially with SHPO and National Park Service and getting those tax credits, how lenient they may be around aesthetics if they see the value add with the performance enhancement.
Yeah, but if the glass is going from clear glass to a, you know low reflectivity triple silver, I can't imagine that the historic people are going to go, wait a minute, we want shitty old glass. I mean, I think they're going to be like, yeah, keep the frame, make it all look the same. There's a little bit of a reflectivity because it's performing so much better. I don't know. I don't do a lot of historic, so, but
They're
I
tough.
think, yeah, I know. My dad called them the hysterical society.
Yeah, it's good. I like that. All right. So any other final thoughts you want to share, and what's the best way for people to contact you if they want to talk about VIG?
Yeah, my email is nick@nze.glass. So if you want to, shoot me a note, I'd love to talk. I'll talk about glass all day. On the single pane retrofit, it's dramatically easier than doing it the hard way, but you still need to have a thorough energy model done, right? You need to bring in a building science person to make sure that this old framing system will be water resistant once you've pulled out the glass and the gaskets. You need to make sure that there's no toxicity in the perimeter sealants, and if there is, you can like cover them in a way that's going to be efficient to the environment. And then there has to be a good ROI. So I don't think it's as simple as just throwing it out there and owners are going to go, let's do this. I think there has to be a concerted effort bringing parts and pieces that most glaziers don't have today to the solution, right? I think that's it. So, that's what I've been working on, getting models built that can show an owner, hey, here's the hard way, here's the easy way, here's the energy model that shows it, here's the pricing for both, here's the ROI, and here's the schedule to do it this way and the schedule to do it that way. And if you can bring all those parts and pieces together, then you'll have a package that owners are going to be able to rapidly turn to.
Sure. This is awesome. Thanks, Nick, for hopping on.
Yeah, it was fun. I appreciate it. And thank you, man. I've never, in my 30 some years in this industry, never have I had such easy access to so many really good questions that are answered by your, LinkedIn and your discussions. And there were things, the first 10 years of my time in the industry, there wasn't any information or anywhere to gather it. It was really hard, and then, the next 10 years, there was some, and online, there's some now, but to have you hit on things that are problems that people face every day and that maybe half the people in the country don't know the solution to in the glass industry, it's really helpful. So thank you for doing that for everybody in the industry.
No, and it's introduced me to people like you. So honestly, that's the best part, gaining all of it and learning and just being able to share with everyone.
Well, we appreciate you, man.
All right, Nick, take care. Thanks again.
All right, adios.